Lesson 5.3 is a continuation of the solving of exponential equations and logarithms that you were seeing in 5.2. But up to this point, most of the time, especially with exponential equations, you were solving them using the common base method. So let us start off first with reviewing or warming up with the first 5 problems on this note-taking guide. Problems 1 through 5, I would like you to pause this video and solve these problems using the common base method. So problems 1 through 5, pause right now and solve them using the common base method. Now, just in case you are unsure what I'm talking about, we are going to do problems number 1, no, not problems, one problem together, number 1, so that you can go ahead and proceed to finish the other 4 on your own. So we look at this exponential function, the 6 to the x minus 5 equals the 1296 to the 5th power, okay? When you are asked to find common bases, you are looking at the base of the exponential function. So in this case, the base on the left side of the equal sign of this exponential function is a 6, and the base on this side of the exponential function is going to be 1296. Now, right now, those bases are not the same. So since you guys are allowed to use your power sheet, you're going to go look at the power sheet and see where you can find the bases of 6 and 1296. So if you come down here to the powers of 6, you see that 6 is going to be rewritten as 6 to the 1st power, and that 1296 is going to be rewritten as 6 to the 4th power. So focus on the powers of 6. So let's go ahead and do that. So coming over here to this sheet of paper, since I need more space, I'm going to do number 1 right here. So number 1, 6 to the x minus 5 is equal to 1296 to the 5th power. 6 is the same thing as 6 to the 1st power. I'm going to bring down the x minus 5 exponent. 1296 was 6 to the 4th power, and I'm going to bring down the 5th power. Now that these bases are common, by the one-to-one property, I can remove them, and now I will distribute the 1, which is just x minus 5, distribute the 4, and get 20. Solve for x by adding 5 on both sides, so x is equal to 25. Okay, so go ahead now, pause, and go ahead and work out problems 2, 3, 4, and 5. Okay, so now take the time to check your answers against the answer key provided on the right. Pause this video now, and then resume when you are ready. Okay, so back to your worksheet, your note-taking guide. So there are many problems on this note-taking guide, but we're just going to jump around and do a few of these problems, and then I will allow you to use the rest of this worksheet for your own practice sake. We are going to dive into solving problems, exponential and logarithmic problems, whereby common bases is not a method that is going to work for us. So what do we do in cases like that? Now, before I dive into those type of problems, let's review a few things that we have covered so far, okay? Now, remember in the first section of our unit, we first learned how to rewrite exponential functions into log functions and vice versa. So the most basic exponential function will always have a value here. We call this the base, raised to an exponent value equals, and our answer is our output value, and we're representing this with the letter n. If we were to rewrite an exponential function into a log function, the base value of your exponential function is going to be the subscript of your log. So you would write log, whatever that base value is, and then at the same level of log, you're going to write the output value. The output value is whatever your answer was when you took the base and raised it to an exponent. That number will go here, or that term will go here, and a logarithm is always going to equal your exponent, okay? They are equivalent. Logarithms and exponentials have the same rules of arithmetic, so to speak. So a log is always going to equal your exponent. So whatever this uppercase number is right here, not even uppercase, this number up here, that value or term, that's what your logarithm will always equal. So this is the most basic exponential function. This is the most basic logarithmic function. So keep those in mind. We won't be using exponent rules in this section particularly, but I just wanted to remind those to you just in case you do not have this noted down anywhere. So keep this in mind. I do need you to recall what a common log is versus a natural log. Common log has a base of 10, and an natural log has a base of e. So when you see a logarithm with an invisible subscript and you see the word log, understand that that subscript is a base of 10. When you see an ln, this is not an I, okay? When you see a natural log with an invisible subscript, that is understood to be the base e. And base e is just an irrational number that's approximately equal to 2.72, just like pi is an approximation to 3.14. It's another irrational number, okay? So we are going to proceed by starting working on number 6. So number 6 is instructing us to solve for x by rounding to the nearest hundredth. Hundredth means 2 decimal places. And our problem is e to the x over 2 equals 11. So let's come over here, and you can work on the back side of your paper if you do not have enough space. Let's go to number 6. Actually, we'll just go over here for number 6. So number 6, e to the x over 2 power equals to 11, okay? Now, first you want to verify when you're solving exponential equations if you can solve this by finding common bases. Now, finding common base right now, e and 11, that's not going to happen, okay? But we do realize that it is written in exponential form, and it's written in basic information exponential form. Our b is our e, our a is our x over 2, and our n is our 11. So it's written in most basic form. So what I need you to do is to convert to log, because common bases approach is not going to help us. So let's convert to log. So from here to here. So I'm going to write log base e of 11 equals x over 2. Now notice how close to our log being, our exponential equation is to being solved. Here is the x that I'm trying to isolate. All I need to do is get rid of this number right here. The 2 is currently dividing. So to undo this, I need to multiply both sides by 2, okay, so that I can isolate my x. So x is going to be 2 times log base e. Log base e is just natural log, so I'm just going to replace it with natural log of 11. And that's my final answer. Since they're asking us to round to the nearest hundredth, you will need to go to your calculator. And I want you guys practicing using the calculator of your Delta Math. You will click on your calculator button wherever it's located on your particular platform. And we're going to type 2 times the, 2 times the natural log of 11. So you press functions. Here's the log and the natural log button, ln, and then I go to my 11. And then right there on the far right, I get 4.79, but 2 decimal places, but 99 has to round up because of the 5. So 4.80 will be my answer that I would type in Delta Math, 4.80. Okay. So there's my first answer for number 6. All right, so let's proceed for another problem. Let's go to number 8. Let me display number 8 before I write it out. So number 8, this is visibly different in setup to number 6, okay? I want you to notice that number 8 differs slightly in number 6. So as we rewrite this problem, I want you to see if you can see what the difference is, okay? Let's go do that. So number 8. Okay, so number 8, 4 times 10 to the 4x power equals to 40. Now, I want you guys to notice that this is an exponential function, okay? But it is not written in its most basic format, which is up here. Basic format is a base to an exponent equals a number. Here we have a base, we have an exponent equals to a number, but this number right here is a problem. We should always have our function that we're trying to solve written in its most basic format, whether it be this one or this one. So right now what I need to do is I need to get rid of this coefficient, the 4. And how do I undo numbers when it comes to solving equations? I do the reverse operation. Right now the 4 is multiplying times 10 to the 4x, so I need to undo it by dividing. So I'm going to raise my paper up here and I'm going to divide both sides by 4. Divide by 4 and divide by 4. So this brings down 10 to the 4x because that become a 1, and 40 divided by 4 is a 10. So now it looks great. Now it is written in exponential form, b to the a equals n. Okay, here it is, b to the a equals n. And I'm pretty excited because this problem is actually done, because notice right here I have common bases. This is understood to be an invisible 1. So I can just get rid of my bases by the one-to-one property. I'm left with 4x equals to 1. In order to get x by itself, I'm going to divide by 4. So x is merely going to be 0.25. And that's what I would type in my answer box in Delta Math. Okay, only because they did specify that it had to be rounded to the nearest hundredth, so they want decimal values, okay? So make sure you are reading your directions carefully. Let's do another one. Let us do number 9. So what does number 9 look like? Oops, I'm giving you the wrong one. Number 9 is 693 times 3 to the x equals to 99. So it looks quite similar to number 8, but I want to show you what can happen sometimes, okay? So let's go ahead and do this problem. So over here, let's go ahead and write number 9. Okay, so as mentioned in number 8, our exponential equation is not written in the most basic form. This piece right here is a problem. So let's undo it just like we undid it over here, okay? So let's divide by 693 and divide by 693. Now, over here it cleaned up real nicely. 40 divided by 4 was a 10. This, not so nice, okay? But I do not want you to look at messy numbers as a problem, because if you just trust your math process, you're gonna be just fine, okay? So here, yes, we hit a brick wall. We don't have common bases to be able to do the one-to-one property and set exponents equal to each other to solve. So when you are in a bind with an exponential equation that you can't find common bases, remember what I said up here, you must convert it into a log. So again, convert into a log equation. So follow the rules of converted an exponential into a log equation. So let's write the word log to stipulate, hey, this is the route we're going. So the log, my subscript is the base of this problem. My base is a 3 of the number 99 over 693. Okay, it doesn't matter, it's a fraction, just write it out, equals to my exponent. My exponent was just the x. And right off the bat, notice that you have solved for x. You're done, okay? Now, the issue here is typing this in your Delta Math calculator, okay? So I'm going to show you how to rewrite this answer so that you are able to type it into the Delta Math calculator. I want you to apply the change of base formula. And the change of base formula says that if you have a log of a base of a number, okay, you can rewrite it in this format. A log of base 10 of n, which is this, so log base 10 of n, and you can divide it by log base 10 of this number, b. This and this are the same values, okay? They are the same value. So I change the equation with base b to be written as a quotient where the base is now an invisible 10, okay? So let's apply this rule to this. Log base b of n, log base b of n is going to be rewritten as log of my n. My n is this number, so that means that it's this number, 99 over 693, over, make it a quotient, over, write the log again, of the b. The b is your subscript. My subscript is the 3, okay? Okay, so again, log of n, so log of n, then I'm going to put my quotient, divide bar, log b. My log b is log 3, equals to x. So let's see how we will type that on Delta Math. Okay, so I went ahead and got a head start on typing this out. So log of 3 goes in the bottom, okay? So log 99 over 693 over log 3, and over here to the right is our final answer, negative 1.77. We look to round to 2 decimal places, so I stand here at 7. The 1 says stay at 7, and I'm done. So, you know, all you have to do is type it out once you've used the change of base formula, okay? And just in case you need to remember this, don't forget that you have the ability of just hitting the divide bar first so that you have a stacked bar, and then you can just proceed to type log. You had another fraction in this particular case, so go back to shift, hit the divide bar, and you have these stacked fractions that help a lot. But anyway, going back over here, the answer was negative 1.77, so x equals approximately to negative 1.77. Okay. All right, so that's how we do number 9. Okay, let us proceed to another section. We are going to now look at number 11. So number 11, instead of being an exponential equation, it is now going to be a logarithmic equation, specifically natural log. All right, so look at that equation. The natural log of 2x minus 10 is being multiplied by a 2 and then added by 19, and then it's set equal to 13. So here's what I want you to do. Let's go ahead and write this problem out on the next page, and let's compare it to the most basic of log equations. Okay, so here's what I want you to observe, okay? Look at this equation of a logarithm, and then look at the basic form of a logarithm equation right up here, okay? Our problem is definitely a lot longer than the most basic. Our most basic requires us to have the log word, the base, the output value, and the exponent, okay? That's not the case with this one, okay? So look, here's our log, our base, our number, and then our exponent. So that means this right here, I'm going to highlight, and this right here are disturbances, okay? We can't just erase them. We've got to undo them, okay? And that's what the process of solving is. So let's force this log equation to look more like our basic equation so that we can even go ahead and proceed with converting it into an exponential, all right? So between these two numbers, what do you think needs to be undone first, okay? Which one do you think? If you said positive 19, that is correct. Minus 19 on both sides, okay? So 2 times the ln of 2x minus 10 is equal to 13 minus 19, negative 6. Now, our job is to get rid of the 2. 2 is multiplying by ln 2x minus 10. So we will need to undo by dividing both sides by 2. Now, that disappears, and we are so excited to see that now our log equation looks like the basic. The ln, which is the log, the invisible e, which is the b, the 2x minus 10, that's the n, equals the a is our negative 3. So it's ready to convert. So let's convert to an exponential equation. Okay, all along you've been doing converting from exponential to log. Now here's log to exponential. So my invisible e is my base. My base to the exponent is equal to this output value, 2x minus 10. I am solving for x, okay? I'm solving for x. So what do I need to do? I need to get x all by itself. So between 2 and negative 10, what needs to go first? I need to add 10 on both sides first. Okay. These two are not like terms. They want exact answers. So I'm just going to write e to the negative 3 plus 10 equals to 2 times x. I need to solve for x. I need to get rid of this 2. So I'm going to divide both sides by 2. And now our x is isolated. And our final answer is e to the negative 3 plus 10 over 2. And that's what you would type as your final answer. Okay? Why are we not putting it into the calculator to get a rounded answer? Because in number 11's instructions, they specifically told us to provide exact values of x. Exact value means do not round. Do not round. All right, ready for the last problem? Let us look at problem 16. We are going to solve for all values of x. Log base 2 of x squared plus 7 minus log base 2 of 3x plus 7 equals to 1. So let's solve this equation. Let's go write this out and proceed. Okay, here's number 16. So this log equation definitely is not written in its most basic form. First of all, we already have more than one log in one equation. You guys know from previous sections that we are able to condense logs, which means rewrite them in one single log form. When logs are subtracting, if the bases are the same, you can rewrite it as one log where you divide. So log base 2 of x squared plus 7 is being divided by 3x plus 7, and we equal to 1. So this divided by this, because when you subtract logs, you can rewrite it into one log and take the output values and divide them. Now it's rewritten in a basic log form, so I can now convert. Okay. The base to the exponent is equal to my output value of x squared plus 7 over 3x plus 7. Now that's pretty much a mess, right? We see an x squared term, so we know somewhere along the line I'm going to have to factor possibly, right? Now, I'm simplifying that 2 to the first power is just 2, okay? So what you're going to do is you're going to take this entire quantity in the denominator, the 3x plus 7, it's dividing by the x squared plus 7, right? So I want you to move it to the other side, multiplying. So the 2 is going to multiply by 3x plus 7. And on the other side, the x squared plus 7 is all alone now. Okay? Now, let's distribute. 6x plus 14 is equal to x squared plus 7. Whenever you have a quadratic term, in order to solve for the x's, you must set the equation equal to 0. So that means these terms have to move over to the other side. I want them to move over to this side because here's where my x squared term is. It's positive. It has a coefficient of 1, so I don't want to move this. It's exactly how I want it. This 6x needs to subtract on both sides. Since there isn't any x terms on this side, I'm just going to put minus 6x over here underneath my invisible 0. This positive 14 needs to move, so I need to undo it. I'm going to undo it under the positive 7 because it is a constant. I need to keep my like terms together. So this becomes 0, this becomes 0, which is the goal, equals x squared. I'm going to put this term first, minus 6x. 7 minus 14 is negative 7. So now I have to ask myself, what two numbers multiply to be negative 7 that at the same time add to be negative 6? For those of you that need the visual, what times what is negative 7? What plus what is negative 6? They're one space from one another, so I know definitely one of them has to be a 1. So it's going to be negative 7 and a 1, negative 7 and a 1. That satisfies both. So 0 equals x minus 7, x plus 1. So there's my factored answers. Now I have to solve. If I set that equal to 0 and solve, x minus 7 equals 0, means that x has to be positive 7. If I set that equal to 0 and solve, x is going to equal negative 1. So far, these are the two answers I got. X equals 7 and x equals negative 1. Now, here's what I need you to always do. You must make sure that you check your work, okay? Make sure you always check. 7. If I put 7 in this parentheses right here, I need to make sure that this answer is a positive answer and that it is not 0. So let's plug in 7 here. 7 squared is 49. 49 plus 7 is 56. So that works. Let's plug in 7 over here. 3 times 7 is 21. 21 plus 7 is 28. So that also works. So this one is an acceptable answer because the answer was always positive. The reason you want to check, by the way, is you can never take the log of a negative number, okay? This value here has to always be positive and not 0. So that's why you need to resubstitute your answer or answers to make sure you're not getting a 0 or a negative number. Let's do it again. Let's do put in negative 1. And you can use a calculator, by the way. I'm showing you here by hand, but you can type it in a calculator. So substitute negative 1. Negative 1 squared would just be positive 1. 1 plus 7 is 8. Okay? So that works. That's okay. Let's plug in negative 1 up here. 3 times negative 1 is negative 3. Negative 3 plus 7 gives me a positive 4. That's a positive number. So I can go ahead and claim this one to be an acceptable answer as well. And it works. And that is what you would type into your answer boxes. If either one of these or both of these, when you plugged it in, failed because the answer ended up being negative, then you will not include it in your answers. So if only this one worked, just put that answer. If both of them failed, then your answer is no solution. Okay? But always, always check your answers when solving log equations.